After completing the course, the students will be able to demonstrate the operations of stacks and will be able to apply stacks to a specific application.
A stack is an abstract data type commonly used in programming languages. Stack is a linear data structure in which the insertion and deletion operations are performed at the top end. In stack, the insertion and deletion operations are performed based on last in first out principle, that is LIFO principle. In a stack, the insertion operation is performed using a function called push and the deletion operation is performed using a function called pop. Now we will see about operations on stack. First one is the push operation. It is the process of inserting a new element at the top of the stack. For every push operation, we have to check whether the stack is full or not. If the stack is not full, the top will be incremented by 1. That is, top is equal to top plus 1. Then insert the element x in the top of the stack. Second one is the pop operation. It is the process of deleting the top element from the stack. For every pop operation, we have to check whether the stack is empty or not. If there is some elements in the stack, then deletion operation is performed from the top of the element by decrementing the top value by 1. That is, top is equal to minus 1. Now, implementation of stack. The stack can be implemented in two ways. One is the array implementation of stack. Next one is linked list implementation. The array implementation of stack is associated in each stack with the top pointer. For empty stack, top is equal to minus 1 it will show. Stack is declared with its maximum size. By performing stack empty operation, initially the stack will be empty. With empty stack, the top pointer points to minus 1. It is necessary to check for empty stack before deleting an element from the stack. Routine to check whether the stack is empty. Int is empty, stack is, if top is equal to minus 1, then return the value 1. Stack full operation. As we keep inserting the elements, the stack gets filled with the elements. Hence, it is necessary to check whether the stack is full or not before inserting a new element into the stack. Routine to check whether a stack is full. Int is full, stack is. If top is equal to array size minus 1, then return the value. Push operation. It is the process of inserting a new element at the top of the stack. It takes only two parameters, x and s. The element x to be inserted at the top of the stack, s. Before inserting an element into the stack, check whether the stack is full or not. If the stack is already full, insertion is not possible. Otherwise, increment the top pointer by 1 and then insert the element x at the top of the stack. Routine to push an element into the stack. Void push int x stack s. If top is equal to array size minus 1, error stack is full. Insertion is not possible. Else top is equal to plus 1. Yes, top is equal to x. Pop operation. In this process, deletion operation is performed at the top of the stack. It takes only one parameter, that is pop of x. The element x to be deleted from the top of the stack. Before deleting the top element of the stack, check for empty stack. If the stack is empty, deletion is not possible. Otherwise, delete the top element from the stack and then decrement the top pointer by rotate to the top element of the stack. Void pop stack S. If top is equal to -1, error empty stack deletion not possible, else X is equal to S top is equal to top minus. Return top element. If the user needs to retrieve the last element deleted from the stack, then the user can return the element into the stack from top. To do this, first check for empty operation of the stack. If the stack is empty, then there is no element in the stack. Otherwise, return the element which is pointed by the top pointer in the stack. Routine to return top element. Int top element stack is if top is equal to -1, error. Empty stack, no elements and return the value 0. Else, return is top. In linked list implementation of stack, the stack elements are implemented by using singly linked list concept. Dynamically, memory is allocated to each element of the stack as a node. The stack in singly linked list is declared with its node type. First, we declare the structure of the node. Type def struct node pointer stack. Type def struct node pointer position. Stack is struct node int data position next. Int is empty stack is void push int x stack is void pop stack is int top element stack. Stack empty operation in the linked list. Initially, stack is empty. With linked list implementation, empty stack is represented as S next is equal to null. It is necessary to check for empty stack before deleting pop an element from the stack. Routine to check whether the stack is empty. Int is empty stack S. If S next equal to null, return 1. Push operation. It is the process of inserting an element at the top of the stack. With linked list implementation, a new element is to be inserted at the front of the list. It takes two parameters, push x and s. The element x to be inserted at the top of the stack is. Allocate the memory for the new node to be inserted. Insert the element in the data field of the new node. Update the next field of the new node with the address of the next node which is stored in the S. Routine to push element. Void push index stack S. Position new node top. New node is equal to m alloc size of struct node. New node data equal to x. New node next is equal to s next. S next is equal to new node. Top equal to new node. In pop operation in linked list implementation. It is the process of deleting the top element of the stack. With linked list implementation, the element at the front of the list, that is S next, is always deleted. It takes only one parameter, pop of x. The element x to be deleted from the front of the list. Before deleting the front element in the list, check for empty operation. If the stack is empty, deletion is not possible. Otherwise, make the front element in the list as temp. Update the next field of header. Using free of function, deallocate the memory allocated for temp node. Routine to pop element. Void pop stack is position temp top. Top is equal to S next. If S next is equal to null, error, empty stack, pop not possible, else temp is equal to S next is equal to temp next, free temp, top is equal to S next. Return top element. Pop routine deletes the front element in the list. If the user needs to know the last element inserted into the stack, then the user can return the top element from the stack. To do this, first check for empty stack. If the stack is empty, then there is no element in the stack. Otherwise, return the element present in the SNext data in the list. Routine to return top element. In top element stack S, if S next is equal to null, error stack is empty. Return 0, else return S next.
Now we will move on to the question and answer section. The first question is, process of inserting an element in stack is called. The option is option A, create, option B, push, option C, evaluation, option D, pop. The answer is option B, push. The second question is, in a stack, if a user tries to remove an element from an empty stack, it is called option A, underflow, option B, empty collection, option C, overflow, option D, garbage collection. The answer is option A, underflow. Thank you, students.